The batteries might get there before hydrogen can prove it's better. Charging speed would probably be of importance for me a few times a year.
And they were discussing what's inside the Tesla battery. I said it's just small Panasonic batteries cramped up together.
Since we discussed battery electric vehicles, somebody says, oh, how did we create our energy? We do it with coal. I didn't know this before.
Yeah.
I mean, the combustion engine is basically a heating device which produces also motion, right? In reality, that's where we are.
Thanks for joining me, Wilhelm, and make a quick introduction, please, of yourself.
First part of my life, physics, basically, academic almost exclusively until more or less exactly 2000. Technical University of Graz, PhD, then an assistant professor, later on assistant professor for physics and material science at Virginia Tech in the US. Decided in about 2000 to leave academia. From then on, I think about 6-7 different industrial positions, first in 3 different semiconductor organizations. First 2 producing, the third was equipment, which brought me into kind of service application work, engineering work. Then I joined AVL, which is my current employer, in 2006. Within AVL, started in the service organization, then went into consultative selling, efficiency work, efficiency meaning efficient use of validation development techniques for quite a few years. And that moved me more or less into a sales role. Since 2014, I'm looking after this strategy, sales and marketing for Northern Europe for AVL. Northern Europe for us is UK and Scandinavia.
Yeah, great. Thank you very much. So, yeah, and as I've been following you a lot on LinkedIn and the developments that you're sharing, of course, apart from the COVID-related topics that we've been discussing also a lot, but today this is all about batteries. And so, talking about batteries, Wilhelm, I'd like to take your opinion on the current status of the batteries, especially that are basically designed and implemented on the electric vehicles, EVs, about their range, their charging speed, the infrastructure, and also especially safety nowadays. So what can you tell about this?
My feeling is that we have reached a quite good status overall. I mean, of course, there are different suppliers, there are different concepts, different charging organizations and everything, right? This is still in a, I wouldn't call it early phase. It is an early phase. It is an early phase, but it's not an infancy anymore. So, in my opinion, the batteries at the moment are something that's practical, that is safe, reasonable to produce, I would say. Obviously, there is much more planned battery capacity production than there is existing at the moment. We have also, in reality, if you look at the battery manufacturers, we don't have necessarily we don't have battery manufacturers with long automotive history. So the veterans are Panasonic, you have LG, Samsung, quite a few more, CATL, and so on. Of course, Northvolt here in Scandinavia, not producing yet full scale, but it's a good intermediate state. It's not an early state anymore. I think it's an early intermediate state. Key for me, I mean, for sure, still technical improvements will be there. There is the ethical part. Where do the components come from, right? Where do we get the raw materials, which has the aspect, social aspect, labor is involved in this. but also an environmental and environmental and probably commercial aspect from a recycling point of view. You can see that the innovative companies, I would call Northvolt an innovative one, because Northvolt has always been focusing on a green battery, on a commercially viable battery. So they have looked at the complete supply chain from start, although they were not even producing. They know that this is one of the central issues. So I see us on a very good way. I need to say this personally. I'm not a fan of batteries at all. I think they are the second best solution.
Okay.
It's not as nice as hydrogen. It's definitely, hydrogen is a much nicer solution.
All right.
The question is it practicable? Is it commercially feasible, etc.? And I think the batteries have come really a long way, and I still think they have a good way to go. So the batteries might get there before hydrogen can prove it's better.
Okay.
Possible.
So
but it's a race. I think it's a race.
If you compare that's an interesting opinion, because if you compare hydrogen to battery in terms of the whole supply chain, in terms of the production process, and the environmental friendliness of the production process, and also the infrastructure, where do you think hydrogen actually is better than battery, and where battery is better than hydrogen? So if you compare the two solutions.
That's a very simple question, in my opinion. Let the car crash and see what happens to a crashed battery and happens to a crashed hydrogen tank. This is a very big difference. After you have an accident with a 1 ton battery or a 500 kilogram battery, you have basically a chemical disaster area. That's what it is. After you have a hydrogen accident, you have just a little bit of a major flame, most likely, or a minor flame. Done. That's it. Okay. You have toxic material to remove. You have a lot of cleanup that you have to do after every battery incident you will have, and every car will have a major battery. By the way, to be clear, also with fuel cell vehicles, they will have batteries, right? So you will not. I think, and this is I think is a very important point. For me, the making a statement on hydrogen being a nicer solution is kind of, I call it a more emotional statement. Yeah. The practical, technological statement is very clear. Fuel cell vehicles will need batteries. Everything we do right now on batteries will never be wasted. Yeah. The battery know-how that we develop at the moment will be needed. Will be needed for hybrids. It will be needed for fuel cell vehicles, and for sure for battery electric vehicles, right? And that's I think it's the beauty of working in the battery area. You know, this will not be replaced in short term. I also don't think long term, actually, which removes a lot of philosophical discussions. Is this effort worth it, etc.? What we do on battery, every step of progress we make there is a lasting progress. I think this is really nice. Actually. All right.
So before talking about the future, because we will come to that point too, in terms of the battery. So let's go back to the present and let's say the near future, where we will still need to develop, work with the current state of the technological achievements in this area. So talking about the charging speed, it's one of the probably hottest topics nowadays. So what is the optimal charging speed, especially when someone is traveling from A to B, and in this commute, the charging speed is something of a practical importance, probably, where you don't need to stop. Because if we compare it to refueling a conventional vehicle, where you just need to spend a few minutes at the gas station, as opposed to battery, where you need to spend, what is it nowadays, at least 20 minutes to get your charge up to 80% or something with the fast chargers. And
that was fast already then.
Yeah, that's one of the fastest ones, probably. Yeah. So what do you think about the charging speed? Do you think that it is something that is really of importance when it comes to electric vehicles, or isn't it?
I do think for assuming a wider spread of electric vehicles, or no, actually, let's turn it around. Looking at the average customer, if I don't drive a battery electric vehicle at the moment, if I would drive it at the moment, charging speed would probably be of importance for me a few times a year, 10 to 15 times a year, because in my daily commute, in my daily use, even short business trips to customers, I wouldn't charge. I would be charging at home, or I would be charging in the office parking space. So I would probably most likely avoid these stops, which I do now as well. With I usually try to, unless the trips are longer, I try to avoid these stops simply for time reasons.
I see.
For efficiency. So I think for the average customer, charging speed is almost irrelevant, except for a few times a year where you have to charge on your way, and of course then you would like it to be 5 minutes, not even 20, right? But 20 is kind of acceptable. 1 hour is stretching it, unless you can combine it with a lunch and so on.
Good.
At the same time, I have to say for myself, what I do right now quite often, when I take a break for refueling, I combine this very usually without having to, but I do it with a half an hour, 1 hour email break. Just checking email and communication break, which I prefer to do rather than having a crash on the motorway, right? I'd rather do it in a break area.
Yeah, that's right.
Without any need, I still do it at the moment.
But that somehow correlates with the duration that is nowadays required to recharge your car, which is about 30 minutes, let's say, in average, right? So in terms of that, if we say that, and I think it's a fair comment too, that practically the charging speed is not of the utmost importance for electric vehicle users, then what is?
I think price is a topic for sure. Price of the vehicle. It's not a topic for the user, but I do think it's important what we do with the battery afterwards. The user doesn't care. I understand that maybe from a purely egoistic point of view. I think to have a circular economy from a battery point of view is extremely important, because otherwise we're just we will create an ecological nightmare with the batteries otherwise.
Yeah, one of the dark sides of the battery that the let's say anti-environmentalists keep bringing up, and I wouldn't say anti-environmental, but those people who are basically anti-EV, they keep bringing it up, and probably that's a fair comment too. So in terms of the charging infrastructure, then, if we talk about, let's talk about Europe first. What do you think about the current state of the charging infrastructure, and where is this going?
What it will be is I think we will obviously have more charging points. I think the majority will charge at home or in the office or at the parking lot, wherever. So that means speed will not be an issue, and I'm assuming from a gas station, an electron station in the future. I think these charging stations, they will have, in my opinion, they have ideally a faster option. This might be a faster option correlated with price as well. It's another battery discussion relative, because you might have actually to back up these fast charging refueling stations or recharging stations with some battery power locally, in order to not kill the grid when you have the large demands there suddenly. So I think that's it's a natural development. You will see charging stations pop up, but the beauty is that you don't need necessarily a station. The requirement to charge is actually much smaller than building a gas station with all the permissions you need and the tank and so on. So you have lower requirements for recharging, and that's why you will see them pop up at every parking lot, more or less. So I think there is also clear advantages to the battery electric vehicles, which make an infrastructure much easier than the infrastructure that we had to build, and we have built for gasoline and diesel. So I see this as, and of course it's critical, because we have now a few percent of our vehicles are electric, so we need more of it. But the hurdle, the obstacle to build this is actually smaller than it is for gasoline stations or diesel. Either way.
Okay, so but how about you talked about the safety, well, the safety implications when an electric vehicle crashes. There are also a lot of nowadays. There are a lot of incidents with the electric vehicles actually catching fire while charging. And I read an article about the convention around the charging stations, because I think they probably don't consider the safe distance required for the cars, and they're just placed at the parking lot where the distances are too close, where if one car catches fire, basically it sets ablaze everything around it. So what do you think about the safety precautions that need to be considered as part of these as this infrastructure grows? Are parking lots good locations for this?
I think they will be, in my opinion. Maybe they are not yet. That's a good point in terms of safe distance. I know what you mean, especially if one starts, right? Then we have seen probably the same videos or some of the same videos. I agree with you.
Yeah.
Maybe it is better to you could simply create a spacing between the different charging spots. That's a simple option. You still would have the vehicles with batteries next, but maybe that doesn't have. Yeah, maybe a parking lot is not a good solution. I agree. I still think that parking lots, in my opinion, will be one of the also in the future of the charging solutions.
Yeah.
I think it's going to be a question of making the batteries safe, because if you, I think you can reach a certain state of the battery side with the battery system. You don't have the incidents we are seeing at the moment. I mean, it is clear there will be, for sure, if we have adoption of battery electric vehicles, whether we are charging or not, we will have batteries located next to each other. So this idea of one catching fire and then setting ablaze everything else will there, whether you have a charging station there or not. That means you have to solve the safety of batteries or battery electric vehicles in general.
So, and now it probably brings us to the next point in the agenda, which is about the future and the vision about the battery technologies. So I have a feeling that, of course, I have a naked eye, and in terms of the technological knowledge and the know-how, but I have a feeling that we are still moving, as you also probably mentioned, that we're moving with the inertia of the available technologies, the technologies and the battery technologies that were available for, let's say, more of the other appliances like cell phones, devices, where we took the same technology, probably make it bigger. We just made it, scaled it up, and then we're now using it in the cars. For example, one of the things that when I was speaking to a bunch of friends, and they were discussing what's inside the Tesla battery, I said it's just small Panasonic batteries cramped up together. So and they were surprised. Oh, isn't it something? No, it's just Panasonic batteries cramped up together. So in terms of safety, in terms of the general, again, the production, environmentally friendliness of the production, mining of those materials that we need. You talked about the ethical point, which I understand where you're coming from. So where is this going? What is the vision for battery technology in the future?
If you, I'm not even thinking you need to look at the vision. You can look already at what is being implemented. I understand Volvo Cars, for example, is now making very nice steps on using blockchain for the origin of some of the raw materials. I think they are starting with cobalt. From what I understand, this has been just shown recently. They have acquired a blockchain-based technology company out through their high-tech funds, if I got that right, and they are intending to use this for the ethical sourcing of cobalt, as far as I know, first application. I do think that companies like Northvolt at the moment are building this already into their complete approach. We call it ethical sourcing, as well as the recycling-circular economy. I do think that everybody else on the battery side will have to follow. If we don't build this into the battery cycle, it will be a nightmare, in my opinion. So it will be a ecologic nightmare. It will be not much better than the current petroleum-based economy, in my opinion. Maybe you can then calculate that there are less deaths or less affected children and so on. It's still it would be a tremendously missed opportunity not to build this in now, and we have the technology, and I think there is the readiness on the battery manufacturer side to build it in as well. So, I think the vision is to create. Sorry to say it like this, but the vision is to create a better future. I have to say, while I think the oil and gas companies were talking about it, I think battery companies are actually making steps. That's maybe a difference. And you see car manufacturers making steps, which was the same when they were cleaning up on the emission side, both the particles as well as the toxic emissions, right? I mean, the progress which was made also on the combustion engine before was tremendous.
Yeah.
It's just that they still will run with CO2. So that's a topic that you will not kill from a combustion engine point of view.
Yeah.
Therefore, the batteries or fuel cell vehicles, of course, have an advantage.
So if you imagine, or if you think of a battery of the future, next generation battery that can be used in electric vehicles, that can be used in many other heavy industry applications, right? What does that battery have as opposed? What are the advantages of that battery as opposed to the batteries of today? For example, lithium-ion batteries or similar.
I think people currently lithium-ion for that, but I don't think it will be lithium-ion based. I think we will have different battery chemistry in the future. Not tomorrow, maybe not in 2 years, but I think lithium-ion is not yet the answer. It's a good intermediate state, in my opinion. And I don't think we can. I don't see at the moment other materials like graphene-based or solid state today. Do I think it's going to come? Yes. I think battery development will be driven massively by the opportunities we are facing in the automotive industry. That will drive some creativity and spirit and bring people into the field that have not been there before. So I remember very well, given my age, I remember very well a time when LEDs seemed still very illusionary as being components of a display or illumination and so on. And there was tremendous progress. There is no reason to believe this is not happening in batteries as well. We have not reached any fundamental physical or chemical limits at the moment. We are basing it, as you said before, we are basing it on what's available. What Tesla did with Panasonic to come to a fast, I think, remarkable status. But to assume this is the foundation for the next 20, 30 years, I think would be very enough is the word. Yeah. There will be better solutions.
Yeah, you mentioned the graphene as a solution, but I sense you don't believe in that so much.
Oh no, I wouldn't say that. With graphene, I have a different problem. I'm a physicist by training. There was a time when carbon, let's say 2000, was the solution to everything. So means fullerenes, graphenes, and everything at that time were the solution for all the semiconductor chips, all the batteries, all the electrodes, even wires and everything. So everything was graphene. I just think we need to see where it's going. I think graphene is a viable option from what I've seen also in terms of behavior of graphene batteries when you, for example, simply put a hole in them. So what I've seen from energy density, storage capacity, resistance to failure, catastrophic failure, or punch a nail into it and so on, these are quite remarkable, but they don't have by far not the development maturity that lithium-ion has at the moment. So graphene has potential, but would I bet on it? No, I would not. I would not bet on it, but I would definitely also not bet against it. It's not a good betting subject.
Right. I think. So, but if we talk about, like, let's say 3 main features of a battery of the future, can we say that number 1 is the production, and that the production is, let's say, from the ethical perspective and from the supply chain perspective, is as efficient as possible, and the second one is probably the charging speed and the overall capacity. And the third one would probably be recyclability, or what we do after the battery after the battery dies.
Charging is related to aging, the way you use it, and therefore aging and charging is the same topic. I'm sure production dash ethical sourcing, clear. I think charging is combined with aging. Yes, possible. I think it's more than 3, in my opinion.
More than 3.
Batteries.
So what would you put in other ones?
Yeah.
Well, what would be your other point, important point?
Yeah, I think people say safety first. So I think it's not a bad thing to start with, right? I think safety is good. Anything you can do to improve the safety. That might also be on how we package it, how we manage the battery charging and so on. This could be one topic. So I think safety is an issue. Whatever we can do to make it safer, because we will have more of these vehicles on the road. I do think the price is a clear topic as well. The price you can address in two ways. You can make the single battery cheap, or you can create a circular economy with it, where the in-use phase in the vehicle can be paid with a much lower amount, significantly lower than the investment into one battery. So that there is an economical, technical way of solving it, I think, on the pricing side. Ethical sourcing we have mentioned. I have not seen a good trade-off diagram for batteries. Maybe it exists and I just didn't see it, but that would be interesting actually to look at, because you have the classics, right? For any aerospace application, weight will be a topic.
Yeah.
So there is quite a few parameters. It's not. I don't think you can say if you solve this and this, you have done it. Very thing is, for safety, I think there is no commercial solution. Safety is a technical solution.
Yeah, definitely.
For price, there could be a commercial and a technical solution. For aging, there is no commercial solution. You can not prevent aging, but you can minimize the impact on your cost with a commercial solution.
That's right.
So I think you need a good trade. I will take this as a homework out of this interview, to have do a good trade-off diagram for batteries, because I think it's needed. It's not a 1, 2, or not even a 3-dimensional problem. I think, in my opinion, I think it has a few more.
Sure.
Makes it attractive as well.
Yeah, absolutely, absolutely. So one of the again, coming back to the anti-EV community, let's say, or the anti-environmentalists, there are different shades of that, right? So and one of the comments or one of the arguments we hear a lot, that okay, you can populate the cities with electric vehicles, but you still need to charge them, right? So you still need to burn something, or you still need to get the energy from somewhere to charge them. So what do you think about this notion?
Since we discussed battery electric vehicles, somebody says, oh, how did we create our energy? We do it with coal. I didn't know this before. I only learned about it since we are building battery electric vehicles. The problem has been there before. It's getting bigger, of course, true. So yeah, it increases the urgency to solve it. But the problem is not new. It's just that it's visible now. So,
but do you think
the motivation to solve it is bigger?
Yeah, but do you think that in overall the requirement? Once again, I mean, I don't know if there is any standard constant unit that you can use to measure all this, but the requirements for electricity, for power, is it in general? If we take the whole supply chain from source of generation, whatever station it is, it can be nuclear, coal, wind, anything, to the end consumer, which is someone who is charging their home appliances, or they're charging, or they're just lighting up light in their apartment, or they're just charging their vehicle in a city, in any urban environment. So by having more electric vehicles and removing, let's say, let's take a hypothetical scenario where we have a city where more than 90% of vehicles are all electric, right? Do you think that the whole energy consumption of that city will be more than another conventional city where electric vehicles are not so dominant?
My understanding is the energy consumption of the city will definitely go down the more electric vehicles you have, because the efficiency of the electric power is considerably higher, significantly higher than the efficiency of the combustion-based powertrains. So that's a given. Overall, energy consumption will go down.
All right, that's interesting.
Energy consumption will definitely go up, correct? So you're moving from fossil energy to for now, unknown source of electric energy. That means you have to clean up the production of the electric energy, energy consumption will go down. We are definitely burning less energy. That's clear.
Right. So overall, you think that, okay, the electrical consumption will go higher, but the overall energy consumption will go lower because the electric vehicles are more efficient. Is that because once again, I mean, one of my counter arguments when I personally counter this kind of opinions is that a normal, let's take an average ICE, like an internal combustion engine vehicle.
Right.
Let's take even one of the most modern ones, which are running on auto start, and they have the most efficient powertrains available, right?
Yeah.
Anyway, I think that the loss to heat while these vehicles are producing their own propulsion is still uncomparable, because you just need to run the engine while on idle, while an electric vehicle doesn't need to do that. You just press the accelerator, the motor turns, you release it, it stops.
Yep.
Yeah.
I mean, the combustion engine is basically a heating device which produces also motion, right? In reality, that's where we are.
Yeah.
That is actually something which is very nice in very cold climates, because the waste product heat is then seen as an advantage, as a big advantage.
Yes. Well, I think we're coming to the end of our time, and I thank you a lot for your first of all for joining me and for your time and great answers and very, very nice conversation. I hope you enjoyed it too.
You mean I passed the test?
No, there's no test. Yeah, but
I would like to say one thing out of the conversation, right? I do think the questions on the battery really made me think whether we have a good way yet of showing these trade-offs, because there is a lot to do there. That's maybe something to really think of. How can we show the priorities on the battery side? That's not a simple game. I think the goals are very clear, but you need to know a little bit more about the trade-offs, and I will dig into this afterwards. That was I need to thank you for this here in the discussion.
Yeah, great. I also look forward to continuing this conversation as I think there are lots of things that we can bring up again, and maybe have some follow-up discussion on your findings. So so thanks, Wilhelm. I really appreciate your time and your support, because this is basically a beginning of something, and having support of you is really great. So I wish you a nice weekend coming up, and stay safe and take care of yourself. Thank you.
I will do that. Thank you very much. Thank you.
Thanks, Wilhelm. Bye.
Bye.
Bye.